Welcome back, students. All right, this week's learning goal, we're going to be to solve all variable equations. All right, and here are the steps to solve the all variable equations. Get these into your notebook, and these are going to be very helpful as we go through and solve it. All right, one thing you kind of got to understand about solving all variable equations is that there's really not numbers. There's not going to be a number that we've come to in a solution like, oh, x equals 2 or x equals 4. No, it's going to be more like x equals mx plus b, or something like that. It's going to be like variables, and it's not going to be a final solution with a number. So understand that right now, and it's going to help you understand moving forward. But what we are doing is we are still using those inverse properties to solve and find whatever variable we are looking for. So some things that you're gonna hear a lot is, here, let's just go through the steps first and then make a little bit more sense. So step one, get this into your notes. Steps to solve all variable equations. Step one, understand what variable to solve for, because it could be solving for the x, it could be solving for the b, it could be solving for any variable in that equation. You could be solving for that. And what it means by that is, say you're solving for the x, you're putting it in terms of x. Or say you're solving for another variable in that, which is like m, you're putting it in terms of m. Or say you're solving for like a b inside of this equation, then you're putting it in terms of b. So whatever you're solving for, that's you putting it in terms of that. That's what it means. So that's like a vocab word you're gonna have this week. All right, so step two, you're gonna use the inverse property rules to reform the equation. So you're gonna start moving things around by using inverse property to get whatever you need to get isolated, to put in terms for. And step three, you're done when you put it in terms of for whatever variable you are solving for. So that's when you know you're done. Like say you're solving for x, when you get x all by itself, then you're done. Let's do a couple examples. They'll probably make a little bit more sense. Get this first example, y equals mx plus b. It's a formula that we hear a lot, see a lot, and let's reform it. So let's say for this one, I'm gonna solve for x. I'm gonna put it in terms of x. So that's my step one. I read it, I know what I'm looking for. Now I'm gonna use my algebra rules to get it over there. So right here, it's m times x plus b. So I got the same thing, I gotta start with my constant. This plus b, I'm gonna do the opposite of plus b. What's the opposite of plus b? Well, minus b. I don't know the value of b, but I know that I could do plus and minus of it. And so what you do to one side, you gotta do to the other. So I'm gonna put minus b over here. My b's cancel, and every time you do something, always rewrite it as its most up-to-date version. So right now I have y minus b is equal to mx, all right? And now I wanna solve for x, so I gotta get rid of this m. M is being multiplied to x because they're right next to each other. Whenever you have variables right next to each other, you know they're being multiplied. So m times x. What's the opposite of multiplying by m? Dividing by m. We gotta divide both sides by the variable we want to get rid of. My m's cancel, and I'm left with this. Look, x is all by itself, and x is equal to all this over here. So I'm gonna rewrite. I always like to write my x in front and everything else in back. You could leave it how you want, but I'm gonna bring my x in front. X is equal to all this. Y minus b over b. And that is my solution. And there's a lot of variability that you could write it. Like say somebody would have put negative b plus y. That's the same thing, all right? So when you're solving all variables, you're gonna see slightly different versions, but they're all should be equivalent to each other, okay? All right, so example 2. This time we're gonna solve for b, same formula. So here, m times x, this whole thing is being added to b. So what's the opposite of adding plus mx? I'm gonna subtract mx, so I'm gonna do minus mx. What you do to one side, you gotta do to the other. All right, now your x's cancel. Rewrite it, and you just have y minus mx is equal to b. Because look, now b is all by itself over there. So that's the solution to that one. All right, so copy that in your notes. Let's do another example. another famous equation you might see. F is equal to M times A. All right, so like say I want to solve for A. So M times A. So what's the opposite of multiplying? So again, ask yourself, what are you solving for? I'm solving for A, and I want to get A all by itself, but it's being multiplied to M. So all you got to do is just do the opposite of multiplying by M, which is dividing by M. M's cancel, and you're left with A is equal to F over M. All right? So that's another example. And you could solve for any letter in that. Like say, I'm gonna do example 2, like say I'm gonna solve for, this time I'm gonna solve for, this time I'll solve for A, so I'll solve for N. So let's solve for N. F equals M times A. It's the same thing, but just the opposite thing. This time I wanna get M by itself, so I wanna get A over here. What's the opposite of multiplying by A? Dividing by A. And now, my A's cancel, and I'm left with M is equal to this thing over here, F over A. All right. So that's another example right there. I got 4 examples, and you're gonna see a lot of different formulas, so just get used to just moving things around. And don't be, it's okay being confused at first, but just start playing with it. And just always ask yourself that inverse property rule. What's the opposite of doing this? And then it should always just guide you like a book. All right? So that's it for today. Hopefully that helped. See you guys next time.